So this is module 8 entitled Network Layer. In this module, we are to look into the characteristics of the network layer. We'll look into some details about IP version 4 and IP version 6. We'll look into concept of routing tables, how a host routes the packet, and an overview of the router's routing table. So again, the network layer is in between the data link and the transport. Uh, Very important component in the network layer is our IP address. So we've looked into IP address uh, in the previous chapter. IP address are being set in our end devices. Okay. The one that sets this is the administrator. So operating system should have this protocol, should have this IP address, and it is actually combined with TCP. So they are protocols suit TCP/IP. So this TCP/IP should be present in the operating system. Okay, and once our operating system has this, the administrator can set up an IP ad. These are these two, the TCP and this one, that one we're discussing, the IP ad, are very important components, both in a local area network and in a wide area network. Okay, uh, they are the ones responsible in providing end devices to exchange data. Their main role is to serve as an identifier. Just like us, we have address, right? The place we stay in has an address, and that serves as an identifier for the delivery boy to know where we are. Same thing here. That's the purpose of the IP address. There are two versions of the IP. IP version 4, the one with the 4 dotted decimal. It's not scalable, especially now at this point. Uh, in time or in the condition of our internet infrastructure. So this is why they came up with IP version 6. Okay, so in this layer, network layer, during transmission, the data is being encapsulated. So uh, the meaning covered by IP address, and then during the receiver, encapsulation during sending. So during sending, again, data is being, sorry, not the data, but the segment, ano? The segment from the transport layer is being encapsulated in the network layer. So that's why the segment will now become a packet. It will be called as a packet. And then during the receiving part, receiving is the packet is to be de-encapsulated, meaning the IP address being removed and processed. Okay, during the transmission, sa example, Mapua Makati, this is Mapua Makati, this side here is Mapua Makati. A packet is to be forwarded to Mapua Intramuros, and there are routers between these two campuses. A router will perform routing. We'll have an overview of routing. So there's a router here, there's also a router here, and one task that the router will do is to perform routing. Routing, in analogy, is uh, the forward. In analogy, what we have in the routing is like it's like a Waze, right? It tells where to route the packet. It gives us direction. That's the purpose of the Waze. Okay. So, uh, in general, the data is being added with a couple of information in, and we call this as a header. Okay, a header. So in the transport, we call it as a segment header. In network layer, we call it as an IP header. Okay. Um, so uh, once a packet is to be received, say again it is being received, the network layer component of our operating system examines the layer 3 address. Okay, there. So IP address does not change. Okay, during transmission, IP address does not change from source to destination. Okay, I will have an example of this in one of the chapters. There is this what we call as NAT, network address translation. NAT is usually set up in a router, and what it does is it translates a private IP to a public IP and vice versa. So there are a couple of terms that I mentioned. So for sure, uh, um, uh, it will not yet give you an idea of what NAT is, but as we go along in this course, we will tackle this NAT. We will have an overview of NAT in one of the chapters once we're done discussing the IP address. Because I mentioned about private and public IP, there's a separate chapter that covers that. And then in your Cisco 2, NAT is one chapter. It will be discussed in detail. It even includes the setup. You will set up NAT in a router. A characteristics of IP is connectionless, best effort, and media independent. What we mean by connectionless is it does not establish connection. This establishing a connection is a role of TCP. Okay, so this is why TCP is partnered with IP. Okay, so what we mean by establishing a connection is IP alone, IP address alone. It does not care if this mail is being received by the destination. Okay, it only cares of of having an identifier. So IP its role is just to have is to place an identifier, and that's the IP address here in the data. Okay. Uh, there. So there's no control information, synchronization, acknowledgement. These terms are seen in TCP. Okay. So and then what I mentioned again, um, it has no notification. So IP alone, the sender will not know if the letter or the data has been received. Okay. So all of these informations here uh, are roles or function of the TCP. Okay? So to make it more reliable, IP is partnered with TCP. Okay? We will discuss TCP in one of the chapters. Another is, well, because it's connectionless, so IP is best effort. In Tagalog, gagawin ang lahat sa abot ng kanyang makakaya. And that's best effort. He will do the best of his ability to send data going to the destination. Okay, it does not guarantee the delivery of the packet. The one that guarantees the delivery is again TCP. Okay, there's a reduced overhead. There's no acknowledgement. Okay, the one that has the acknowledgement is TCP, and it does not know if the other device is working or not. The one that knows that is TCP. Okay, and then media independent. The example, you have wireless connection. Can IP work on that? Yes. Okay. IP, it does not care whether if you're using copper, twisted pair, coaxial, wireless, or fiber. Okay. For sure, IP will work on that. Okay. Um, IP is unreliable. Those items that were discussed here are roles of TCP. Okay, example, it does not have means to manage corrupt packets, or cannot retransmit, or cannot identify sequence of the packets. The one that does the sequencing of the packets, resending, and managing corruption of managing corrupted packets is TCP. And now let's look into IP version 4 packet. Again, during transmission, data is being encapsulated with added information, covered with added information. So in the network layer, uh, we are to tackle those added information. Again, we call it as packet. Okay. The purpose of those added information here in this layer, network layer, or the network header, is to ensure that the packet is sent to the correct direction, and that's because it has that identifier, the address. Okay, it contains information for network layer processing in various fields also. And the information in the header is used by layer 3 device like the router that handles the packet. That's very important concept, huh? That the router, which also falls on the network layer, whenever it processes the packet, it receives um, very important information that it looks into is the IP address. So I have here specific contents of the IP version for packet header. We have the version. Version indicates here if it's version 4 or version 6. And then the header length. And then we have here the QoS mechanism applied to this packet. Quality of service is discussed in Cisco 4. We have the total length, total capacity of the packet. Okay, that includes the header plus the data. Other added informations are identification flag, fragment offset, and header checksum. Error detection, if you remember, that's the use of the checksum. Layer 4, it is indicated in the protocol. It is indicated here the layer 4 protocol. There's the time to leave set. Example 255 milliseconds. Okay. Um, the example, the time to leave is 255 milliseconds. So the packet should reach the destination before 255 milliseconds or to a device, say a router that can regenerate the signal. Okay. And then very important here in the packet is the IP ad, right? Source and destination IP address. So I have here the description of the different fields in the IP version header.